Hello, I'm Robin Vincent and welcome to Molten Modular DIY. You find me stuffed into my little DIY corner, and I wanted today just to bring you the simplest guide to soldering Eurorack kits, both through-hole and surface mount. Ooh, I know that's a bit scary, but don't worry, this is going to be simple. Just a little bit of guidance before my big DIY week, which I've got coming up in about a week. I thought it'd be good if we just started off in a position where we know what we're going to do and have the barest amount of gear, the barest amount of skills in order to attempt a little bit of soldering. Because I believe soldering should be for everyone. Too often we see barriers to entry, whether it's expensive equipment or high levels of sort of education skills required. No. Not that I'm saying any old idiot can do this. It takes thought and it takes a little bit of preparation, but there shouldn't be any reason why you can't pick up a soldering iron by the right end and achieve something in regards to building a little Eurorack kit like this one. So this is my simplest guide to soldering, the things you need, how to do it, a bit of an example of how you do that with both through-hole, which is the simple stuff, and surface mount, which is the crazy bonkers stuff, but that can also be simple too. It won't be particularly structured, it will be waffly and a little bit all over the place, but hopefully if you just sit back, grab a coffee, let me talk you through what it is we need to have together in order to do a bit of soldering. Now I should stress, I'm not an electrical engineer, I'm just some bloke having a go, enjoying building kits. I've now built several, and during that time I've received an awful lot of advice from very lovely people telling me exactly where I'm going wrong and what I should be doing and all the gear that I should be getting. Now I'm kind of paring that down. I'm sort of navigating my way through that to try to give you the essential stuff so that you don't get overwhelmed, because any sort of overwhelmingness, it just makes it harder, and then the barrier to entry starts getting higher and you can't get in. You go, oh sod it, I'm just not going to bother. And you should bother, because soldering is awesome. It's awesome. It's the most fun you can have in a tiny little corner of your shed somewhere. So let's kick off with the gear then. That seems to be the stuff that you need to think about first and foremost. What do you need to do soldering? You need a soldering iron. Yes, you do. Soldering iron. Here we go. Here's a soldering iron. Now, anyone that you see doing videos online with soldering is going to have a proper posh soldering iron. The one I've got here, the Heiko FX888D, is a superb soldering iron. It costs about 100 odd quid, and I bought it because I was doing a lot of soldering. Now there's no reason for you to have to get a posh soldering iron. You can get any old bit of rubbish. For instance, before I got my posh one, I was using this. Now this cost 20 quid from Amazon. It's just a soldering iron. You plug it into the wall, it heats up, and you solder with it. So what's the difference between this and the posh one? Well, simply put, the difference is that one heats up really quick it heats up. It has a temperature gauge on it so you can tell it what temperature you want it to be, and it's just made of a higher quality bits and pieces along the way. There's no reason why you can't use a 20 quid soldering iron from Amazon to solder the sort of things we're going to be doing. That is absolutely fine. If you're going to make a massive hobby of this, going to do it a lot, then get a better soldering iron. You know, that makes some kind of sense, because this one is, will break eventually. The other thing is, it's not, I mean, this particular one does actually have a little temperature dial on it, but I wouldn't believe a word it says. So you don't have a whole lot of control over the heat that this is putting out. Does that matter? No. I mean, soldering irons are designed and built to do stuff with solder, and so it's going to get hot enough. That has to be the way, doesn't it? But it may mean that you take longer with a lower quality soldering iron. You might have to hold it on the components longer for the heat to transfer, because there may not be quite so much heat inside. So those are the considerations. But just a soldering iron, a 20 quid soldering iron from any old electrical shop or from Amazon will do you fine. Hopefully it will come with some kind of holder, because you don't want it sitting on your desk, because it gets hot. Yeah? And ideally it will come with a little sponge, which I'll show you in a moment. So I'm going to bring in my super duper super duper soldering iron like so. You see that? You see? Now this one comes with a little holder, which is great. I can just put it in there and don't have to worry about setting it down somewhere. It also has a sponge here, and it has some brass stuff here. Now those two things are helpful because they help keep your soldering iron clean. If the end of your soldering iron is not clean now, must remember that this one is on and it's already hot. If you don't keep it clean, it's not going to do very well. Now this at the moment, if I put it under here, this, I haven't used it for a little while, and so it's not looking that great. It's not looking that great at all. So I might have to do something about that before I start. So let me show you what the sponge and brass thing is all about. They are just cleaning things, simple things. So I get a little bit of water, put it on my sponge. Like that, it draws it in, it's just water onto a sponge. It's that simple. And then when you put your soldering iron into it, it'll fizz, just a little bit. But that, if you like, what that does is it sort of instantly cools the solder that's on the end and helps you sort of wipe it off. And now you can already see under here that I have more of a silvery end. Yeah? That's good, that's cleaner. Now with the brass stuff, which is in here, I've also got one of these things. These are very cool because they look awesome, like little robots. They look great. It's just sort of brass wire, like steel wool in there. And you just jam your soldering iron in, and that scrapes off the excess solder. And again, this is now looking under here nice and shiny, much shinier. The next thing you want to do is probably tin the end of the soldering iron. Now that's a weird, no, it's not a weird term at all. It's a posh, it's a proper engineering term, tinning things, which is when you just put a little bit of solder on it. So I'll put this under here again so you can see. And all I'm doing is applying a little bit of solder to the soldering iron. You can see that it melts. And once I've done that, I'm then going to give it another clean, and that's now looking fantastic. So next up, we should probably talk about the solder. Now there are two types of solder. There is leaded solder and there's lead-free solder. Leaded solder, poisonous; lead-free, not so poisonous. Now leaded solder is what we've been using for donkey's years. As long as there's been electronics, there's been leaded solder because it works really well. It's just brilliant. It flows, it melts, it connects things together brilliantly, and that's why people who build electronics generally love leaded solder. Now the poisoning bit, we don't like that particularly, but unless you're doing soldering for a living, really, the chances of poisoning yourself are low. However, if you're handling leaded solder, then wash your hands before you eat. Yeah? So your other option is lead-free solder. Now, should you get lead-free or should you get leaded? Those are the questions. Now, the simple answer that I came up with through my use of both, I started off with lead-free because that's what I had, and then I moved to leaded and went, oh my goodness, this is so much better. So that is, if you like, is the reaction one gets between lead-free and leaded. Now lead-free is fine, and as far as I understand it, lead-free solder these days is getting better all the time. It works better, it flows better, it melts better, but generally speaking, you have to run your soldering iron much hotter to melt lead-free solder, and it doesn't look as shiny, it's a bit more globby, and it just doesn't quite work as well. That's all I can say, really. But it also depends on your solder. You can get crap solder on both sides, I'm sure. And this is the sort of solder that I use. This one. This has become my favourite. Now, I haven't tried out loads and loads of different types of solder, but I got this one in particular because it says world's finest solder on the bottom. You know, therefore it's got to be good. But I think what's important when you're buying solder is that it has a rosin core. It has flux in the core. What does that mean? It just means that you've got your metal, right? And up the middle of the metal, they've stuck this stuff called flux. Now, flux is this chemical, this material that makes the solder flow really well, and it cleans as it goes. So it kind of cleans oxidation out of the way so that the solder has a better chance of sticking and conducting properly. So a solder with a core of rosin or flux, whatever name you wish to use, is what you want. It makes soldering a whole lot easier. Now, you may have noticed when I was tinning my soldering iron, like so, that there was smoke. What is the smoke? Is it molten lead? It's molten lead? Is it steam? Lead steam. Lead steam is what people like to make you think that is. No, it's not. You can't really take a metal to boiling point with a soldering iron. What that is the flux. Is the rosin that comes from the center of the multi-core rosin core solder. So it's not metal in a gas form. However, it is still toxic. It is full of all sorts of chemicals that are not going to do you any good. And if you spend all day soldering, breathing in that stuff, you're not going to feel well. It's not going to do you any favors. So it's good to not breathe that stuff in. How do you do that? Well, I've got a little fan over here. You see that? Yeah, you can see that. So I turn this fan on. It's just a little fan, a little USB fan, and that's now blowing across my soldering area and hopefully moving the flux out of my way. So let's put this here. See? Now it could be blowing it directly into me. I might need to angle it a little bit more, but you know, that's the idea. The idea is that it blows away because I'm going to be sitting in here a bit more and it's going to go that way. So that's going to work. So I would recommend a fan. You don't need some kind of carbon capturing device or a hood, ventilation systems. You know, just keep the window open, try not to breathe the fumes. If you've got a little fan to blow it out of your way, fantastic. Do that. That's enough, I think. That's enough to keep you safe. While we're talking about safety, the other thing I would recommend is some safety spectacles. They're not sexy, I suppose, particularly, but they are good to the point of being vital. The reason being is that solder can spit. When you're soldering, you tend to start leaning in and get closer to it as you're doing small work. And the solder can spit. You're heating it up, it could spit, and if you get a bit of solder in your eye, that's it for your eye, really, and it's not worth it. It's absolutely worth feeling silly and a little bit uncomfortable in safety specs in order to save your eyes from being destroyed, I would say. So those are good, and of course you'll forget to wear them and such like, but you know, you've got to do what you can to mitigate the risks. Yeah. So highly recommend a pair of safety specs. So with a soldering iron, your safety specs and some solder, you're kind of good to go. But there are a couple of other things that would be useful to have. A pair of wire cutters, these snippers type things here for snipping off legs and other bits and pieces. They're not for grabbing and pulling, they're for snipping. So those are very, very good. Spring loaded, yeah. Spring loaded, doing, those are good. Pair of regular sort of needle nose pliers, those are useful, not essential but useful. The other thing would be a solder sucker. This is a particularly posh solder sucker that I got from Thonk, and it is the best solder sucker I have ever had, without a doubt. What does it do? Suck solder. Clue is in the name. Now, what this is for is taking excess solder off a board. If you've stuck a whole load of stuff on and it's all gone glub, 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 you use this to suck that solder away. Or if you're trying to desolder something, so you're trying to pull a resistor out of something that you put it in by accident, you can use this. Now, other people use stuff called wick. This stuff, super wick. I don't really understand it. I got some thinking I need that, and then I don't know, solder sucker works every time for me. This stuff, I don't know. I think you're supposed to put it on the solder in it. I don't really know. In the comments you can tell us all about it, yeah, but I don't quite get that stuff. But maybe I'll use it at some point, who knows. But otherwise for me, solder sucking seems to be working really well. This is another little tool that I found. It's an IC straightener. Now when you get an IC, an integrated circuit, which is, oh, I don't have one to hand, but you know, that black stuff with all the legs on, black chunk, legs on, when you get that, the legs tend to be splayed a little bit, just enough so that you can't actually fit it in the flipping socket. And so what you can do, you can take it and then you sort of roll it gently in order to straighten the legs, and you know, and that's good, that's good. But this little device here, you just pop the IC in, you squeeze it together, and it straightens all the legs. Just brilliant, brilliant. What a useful little piece of plastic that is. What's it called? I know, IC leg straightener. I don't know. Again, if in the comments if you know what this is, then stick us a link in. That'd be great. The other thing is this. Now this is a complete waste of time, but people recommended it to me over and over and over again. And it's a resistor leg bender. The idea is you take your resistor and you put it across here, across the end of this, and then you can bend the legs down like that. Like that, you see? And now I've got my resistor with its legs bent. I have yet to find a circuit board that this is the right size for, that it's bending resistors to the right size. It's never to the right size. So you're still having to bend it, you're still having to manipulate it. And honestly, the fuss with putting this in here and trying to get it right and then bending the legs takes more time than it does to simply go, oh look, there's a resistor and I've bent the legs. Waste of time, complete waste of time that, so don't get one. Okay, so so this is all covered in cobwebs, right? This is one of those things that you're supposed to get. It's called a helping hand thing, I think. Helping hands, could be, I don't know. The idea being that you set it down, you put it down. See, I'm going to ham this up now because I don't like these. And you clip on your PCB like so, like that, you see, and you've even got a magnifying glass. And if you can get it exactly right, you could potentially use the magnifying glass at the same time. I got that in there. And then you take your solder and your stuff, and you solder things, and it just falls. And it, yeah. What I'm saying is that people use these. I bought one. I can never get it tight enough. I can never get it to hold the thing in the position that I want to hold it in. I find them annoying, frustrating. The magnifying glass can be useful at times for looking at stuff. So that's why I keep it around. But otherwise, the spiders are playing on it and they're having a lovely time. So use one of these if you like, if you find that useful. Personally, what happens with me is I tend to push too hard on the PCBs. I just do. I seem to be somewhere in my brain it says if I push really hard, the heat will go in harder or something. I don't know. But this is just not strong enough to hold something that I'm trying to solder, and I push it all over the place and it just gets annoying. So I don't tend to use one of those. The other thing you can get is a vise, a little vise that holds it. And that seems like a better idea to me, but I've just never got around to it. So what do? I use anything that's knocking around. Bits of old crap, like sponge or something that came out of the kit, and I tend to, you know, lay it down on things and solder it. I tend to just lay it down, balance it on things, solder it. That's what I do. Yeah, so that's just my way, man. I mean, it's simple. And I'll show you in a minute, because I think we should probably solder something at this point. But before we get that far, there's just, I think, one more, which is this, which is a pair of tweezers. Now this pair of tweezers is for surface mount. I'll do some surface mount at the end, because I think that it's something that should be more talked about, because I'm just trying to get the ends of that just to meet up properly, because people tend to be afraid of surface mount. There's no need to be afraid of it. I've really got stuck into it and I think that's actually all right, he says. It's tricky, absolutely, but it's not impossible. And certainly from a simple basic point of view, a pair of tweezers and a soldering iron, you can do it. Now I know people talk about ovens, they talk about heat guns, and I don't know, trays of sand that you bake stuff in and then you set fire to it. I can't really comment on any of that kind of stuff. But surface mount with a component, pair of tweezers, soldering iron. You can do it by hand. You can. You don't have to be a pick and place computer generated something or other, and you don't need an oven. You can just do it by hand. If you're doing tons, then yeah, sure, whatever, get the right equipment. But if you're doing a Eurorack module which has a little bit of surface mount, then you can do it. You can do it with a pair of tweezers. And perhaps something like this. Because that's always good. You do need magnification if you're doing surface mount, particularly with somebody of my age, with my eyes. I need to be able to really look in, because those PCBs can get small, those components can get small, the writing on it can get small. So again, use a magnifying glass if you like, but getting something like this, or a loupe, something which, you know, like a jeweler's little thing that comes in here or goes in your eye, yeah, use that. Anything which is going to give you some magnification, because otherwise it can be quite a strain. But we'll come on to surface mount in a bit. I want to have a go, first and foremost, with this little kit here. Now this is the Swerve from Cereal Instruments. It's a switch. It just allows you to switch something from something to somewhere else. It just comes with a bunch of patch points and a knob. It's passive, it takes no power, and it's just a router. Put something in, turn a switch, and it goes to a different destination. That's it. Very simple, great place to start. But before I do the actual kit, I'm going to attempt to poorly solder a resistor to this board. Now there's no resistors on this board at all, so this is kind of nonsense, but I thought I would just do it as an example of because you're going to be doing a lot of resistors. So let's solder the resistor to the board, and then let's desolder it. Yeah, do that process. That sounds exciting. God, wow, this is great television. So got me board, got my resistor. Now of course resistors have bands on it which tell you exactly what it is, and hopefully in your bill of materials it will tell you what they are and what they should be. So I'm going to put this through a pair of holes that I'm pretending that it's going to be soldered through. Now of course, you know, if I was using my helping hands it would be held up in the sky and I could then solder it, but I'm just turning it over and putting it down like so. Now when you put a resistor in, you can splay out the legs. I mean, if you want to see me doing this on larger kits, on proper kits, and talking you through it, then I have a lot of videos in the channel that show you exactly how to do that. Starting with the touring machine, which was the very first thing that I've made. I've now got a good dozen projects that are on my YouTube channel that you can watch me build and comment on and talk about and see how I developed as a soldering person along the way. So I've put that in, I've splayed the leg so that it doesn't fall out, and I'm going to put it there. Now the solder that I use is only 0.7 millimeters in diameter. It's quite thin, but I've found that that really works for me because it melts quickly, and I can always use lots of it rather than using less of something that's thicker that takes longer to melt. Yeah, so that's what I'm after. So I'm going to put a load of solder on this, and then we're going to desolder it. So what do you do? How do you do it? What's the plan? Do you stick solder onto the iron? No, you certainly do not. What you do is you put the iron onto the pad behind the leg. You're trying to heat up the leg and the pad, really. So the pad is the gold, coppery, silvery stuff that's already on the PCB. So I'm pressing on that. Maybe I press hard because I'm trying to keep the thing still. Maybe that's it. And then I'm going to bring the solder up to the other side, and with a bit of luck that should melt, as you see, and I'm pushing it in. You remove the solder first, then the iron, then we can have a look. That looks pretty good. That looks pretty good. Now what you're after is like a small volcano, like a hill. You want it to be shiny, you want it to be around all the sides, all the way round, and it needs to go up like a spot, like a mosquito bite, like a volcano, like a zit. That's what you're after, a nice sort of silver zit. That's cool. That's not going anywhere. Now if I was going to finish this off, I would take my clippers and I'd clip off the leg. remembering to put my safety goggles on. I've always got my safety goggles on. So let's try the other leg. So again, same idea. I put the soldering iron on first. I mean, the type of tip that I'm using is very much a pointy tip, but it's not necessarily the end of the soldering iron you're trying to use. You're trying to use as much of that as possible, because the more contact you have, the more heat you've got. So you kind of placing the tip in there, but you're also sort of leaning it in, trying to get as much contact as possible. And after a moment, it should have heated up. Stick the solder in. I'm going to put a whole load in this time, like so. Took the solder away, took the iron away, and there you have a pretty over soldered resistor. Now that's too much. I've put too much on there, and it's probably, if I'm not careful, going to perhaps touch on the component next to it. That's no good, you don't want that. So I want to take that out, and I want to remove the whole resistor anyway, because that's not what this project is about. Now, removing stuff is difficult, particularly if you're doing it sort of loose and free like this, as opposed to having it in a vise, because you're going to need to pull against it in order to get it out. So the first thing we need to do is use our solder sucker. Now all this is doing is you're hitting a button. It's got a spring, and it's just literally sucking air through this end here. And this end on this particular solder sucker is really good, and I can push this right up against the component, because it's not going to melt, because it's made from some kind of unmeltable something or other. So you push it down and it comes out. So down here somewhere, I'm going to need to heat up the solder, and once it's bubbling, I want to get the solder sucker in there and press the button, and hopefully that would have taken a whole load of the solder out. And as I push this down again, it comes out the end. There we go, all that solder I took out. Fantastic. Do it on the other one as well. Heat that up. Okay, I've taken a lot of the solder out, but it's still not actually going to release the resistor for me, because it's still stuck to stuff. So I can try a little bit of sucking on this side, which I think would be good. Now I'm sure people watching this are going, oh, I see, mate, if you'd used the braid stuff, if you used the wick, it'd all be done by now. Oh well, maybe. There we go, that one's empty now. I mean, if you are trying to undo something, it is a massive undertaking and a bit of a faff. And if you're not careful, you'll find yourself burning either the PCB or components, because you don't want to be holding the soldering iron onto things for too long. Right, so that is still stuck. So what I'm going to need to start to do is start getting aggressive with it with a pair of pliers. So I'm going to have to try to work out a way of pulling on this while heating it up on the other side, so I can start to move that through. Maybe if I put it on something, then I could push it down a bit. So holding it, melting it, there we go. There we go, and this one. Right, so had some success on one side. Let's pull that all the way out. So I've now just got to pull on this one. So let me try to do the same thing again. There we go. Ta-da! See, that was easy. Are you still with me? Yeah, I think so. So there we go. So I soldered something in and then I desoldered it. Fantastic. Now let's just do this little project and then we'll do a little bit of surface mount, okay? So this is the Cereal Instruments Swerve. Which way round do things go? So all it's got, right, is this great big pot and a bunch of these patch things. So I think I can very easily see, I think, where it goes. Can I? I don't know. So here's the PCB. This is a very, very simple one. But on most PCBs you will have printed on it a representation, a graphic if you like, of where everything goes. So little pictures of resistors and diodes and bits and pieces. But on here all we've got is these patch sockets. And so it shows us that it needs to go exactly there. And it really is that simple. I mean, with a more complex build, you follow a bill of materials, a BOM, B-O-M, bill of materials, and that lists every single component and its number. And those numbers are ordinarily printed on the board. Like these are printed as J1, J2, J3, that kind of thing. And that refers to the document which tells you what these are. Now, this is so simple that you don't really need to refer to it. You just follow the picture on the board. But the combination of using the BOM, of using what's printed on the PCB, and also the instructions that hopefully the manufacturer has given you, those are the things that allow you to place the components in the right bit. Is it easy to go wrong? Sure. It just takes a little bit of concentration and thought. I mean, I haven't thought about this too much, but that just seems to work. Putting them in like that, yeah? Now, of course, when I'm going to go to solder these, when I turn it upside down, they're all going to fall out. So that's not what I want. I don't want that. So I'm going to have to be clever. Now, I can tape them down. This is the other piece of useful thing you can use, is masking tape to tape things down. That's definitely a possibility. But on this occasion, I'm going to use this piece of plastic I've got knocking around. It's just a piece of plastic. I think it came off one of my lights. And I'm going to stick it down like that. Turn the whole lot upside down. Keep applying the old pressure. And there it is. It's all good. It's all good. It's all there. Give it a little bit of movement to make sure that it's more or less level. Soldering iron, solder. Get to it. You can start anywhere. It doesn't really matter as long as you all do it. Now these are particularly large sort of holes that are going to take a little bit of solder to fill. So I'm going to start at this end, heat up at one side, present the solder, remove the solder, remove the iron. And we have jets flying overhead today. That's nice. In order to help with the stability of the board, if I then do something up the other side, up here, then that will help or stop it from rocking about the place. So you sort of do opposite corners, if you like. Do you see that? See how easy that was? So I'm going to go back over here now. So I put this in here to heat up this particular bit, and I stick solder in it, and it just does it. The fan is blowing away the flux. It's just flowing onto there and producing this lovely sort of volcano type look. So a little bit of heat. Add the solder, take the solder off, take the iron off. That's what you're after. Now you can see the end of my soldering iron is starting to get a little bit black in places, so I need to jam it into my brass stuff to get it nice and silvery again, or into the water, or a bit of both. And then it heats up quicker and better every time. Now another rule of thumb when dealing with placement of components and such like is just to say that start with the lowest stuff first, by which I mean the stuff that's closest to the board. Because if you're putting components in and then turning the board over to solder, which is what you normally do, then if you want it to rest, do the stuff that's lower down first. If I do, for instance, if I had done, I've got everything on there. I've still got a couple of spots to do. If I'd put this on first, I could have done that. That would be great. But when I came to doing these, I wouldn't be able to lie them down flat because this was sticking out. So generally speaking, you start with the resistors, which are the smallest thing, then the capacitors, and then the bigger bits like this. Otherwise, you'll be turning something over and it'll probably be falling out. But that's where your masking tape comes in. There's always a workaround, but those are all looking pretty good. You know, physically try them out. That's also good. So those are all in. That's exciting. Relatively straight. Then the only other thing is this fella here. Which way up does it go? I do not know. It says the switch only fits to the PCB in the correct orientation with rounded section at the top. Rounded section, this bit at the top. Okay. Of course, I really stuffed that all up with my resistor soldering. Okay. Pushes in nice. So in order to stand that up to solder it, that will work just like that. But otherwise, a little bit of support to keep it straight, you know, is no bad thing. But that's in there nicely, so I'm not going to worry about that. So again, I'm going to do one here, and then one on the other end. Woo! See, now it's fallen over. In order just to get opposite corners are helpful in keeping things straight. And then you can do the rest. See, if I take this away, that would also be better because it's a bit more grippy on the green stuff. Now my green mat, in case you're interested in that, is just an anti-static mat that I've got knocking around from when I was building computers. It's not special or anything. It melts if you lean on it too hard. It just seemed like a good thing to have rather than just varnish on a workbench. Right, that's all done, I think. Now at this point you can get out your magnifying glass and just check things a bit closer. Oh, I got one I missed. See? I didn't see that. I got one I completely missed. So it's always important to check. Always. Good. So now I've got this thing here which does that. So the front panel then goes on like that. Now it says in my little instructions here, I mean the instructions for this this much instructions, not a whole lot, but it says leave one of the switches nuts under the PCB and one on top. You can see that it's got two nuts on and it's kind of making it too high, so we take that off, undo one of the nuts, put that on top. That's much flatter, much flatter. So I need the bits from here. I put the nut on, tighten that up. Sort of finger tight really, doesn't need to be incredible. I mean the front panel on this is just a bit of PCB, so it's not going to survive if you try to do it too hard. Now these little nuts on the top of here, that'll hold everything together. They do have a couple of little nicks in them, which allows you to get a bit of purchase if you want to do them up, but always have those sticking out the top. Super. then I've just got a knob. There seems to be 3 positions. Has that got a screw on it? Yes, it has. See, it's got a little screw on the side for tightening it up. So once I've put it on, because it's just going to spin around, I want to set it to the position I want it to be on. Then I need to find a little screwdriver. That's probably too big. And you can turn that till it's nice and tight, and that should give you a perfectly working little knob. So that's a nice little thing. Look at that. It's passive, as I say, doesn't require any power. It's just going to sit there and change directions of things. I don't know exactly. I think you've got 3 switches. You put something into the top, got two lots of it, and on switch 1 it goes out that way, switch 2 it goes out that way, switch 3 it goes out that way. Easy, eh? Interesting. 3-way 2-pole rotary performance switch. Nice. Now I will be doing a whole load of different kits during DIY week. I mean, I've got a whole back catalogue of kits and videos on that you can watch, but for DIY week I'm going to be doing a couple of kits live on live streaming right from here, doing it live so that you can follow along and do it at exactly the same time, and we'll see where we get. It may take hours. We just don't know. We don't know yet because we haven't done it. We don't know. So if you're interested in following along, you can get the kits from Thonk. I'm doing the Frequency Central Stasis Leak and the Robo 3PT, doing 2 of them. But of course you might be watching this after the event, and that's fine. It's all going to be available in the YouTube channel, so do go and seek them out. But in building those, hopefully it will demonstrate more of how I do things, how I solder things. Whether that's right or wrong, I don't know. I'll just be taking you through it, because it often, you know, when you see someone do a kit on video, it's always edited down or it's speeded up, all those sorts of things, and you perhaps get the impression that it's dead easy and nothing bad ever happens. That's not my experience. Bad things happen all the time. And we're going to be doing that together. So that's going to be like an unedited, real live streaming of a kit build. Interesting. Now, onto the surface mount. Now, I'm just going to do 1 or 2 just to sort of demonstrate that it's possible to do. But I'll be doing a lot more of that soon. I mean, if you want to watch me do surface mount stuff, then check out my videos on the Deckard's Dream. There's a whole load of that, and I'll be doing a live stream of some Deckard Dream building as well during DIY week. So there'll be more videos out there of me doing surface mount, and I have talked about this before. And it is one of those things that people go, I can't believe he's doing this. What an idiot. Why doesn't he use a heat gun? Because I have no clue how to use a heat gun. I have no idea, and I found a way of doing surface mount which just seems straightforward to me, and so I'm going with that. That's what I'm doing. It's easier if you're doing all surface mount components to, I'm sure it's easier to stick all the solder paste on or something and then heat it with a gun and it all just goes beautifully. But I'm doing these things just one by one, just, you know, just bubbling along, man. So for this little tiny demonstration, I'm only going to do a couple of bits. I'm going to be using the Infinite Machinery ADSR, which has a lot of surface mount on it. I'll do a full video on this at another point, but for the moment I just want to do a couple of surface mount components. I'm going to need to find the build guide. I'm going to need to find the build guide for this. So I'm not trying to say by any means that surface mount is easy. It's not easy. It's tricky, particularly when you're dealing with surface mount integrated circuits like these ones here. Those are different. I'm not going to do that right now. You can see how I did that when you have a look at the video for this kit in its entirety. What I'm interested in this particular instance is just a couple of these, just to show you how I approach it. Now, the bits that I need are in here somewhere. These are tiny things. You get into a little bit of a problem with your fan. Your fan can blow these things away. So it's important that you look after them and make sure that they don't disappear, because if they go off your desk onto the floor, then that's it. That's it, really. They're gone at that point. So let's see if I can find the first bits that I'm after. I want C1, 2 and 3. Now often if you're doing a big surface mount project like the Deckard's Dream, you will get these little weeny little buggers. You'll get them on a reel, and you have to sort of strip them off and they all come falling out all over your desk. That's not quite what we're doing here. I've got it's like an individual one all by itself in a little packet. So I need to find where this is on the board. There's C3, there's C1, there's C2. Okay, so they're all on this little spot here. So the method that I use, I think, because sometimes it changes, I try to keep it consistent, is I heat one of the pads. So this pad here, you can see that. This is going to be C3. I'm going to heat the pad. And then I'm just going to put a blob of solder on it. Now it's remarkable how well this works, in as much as you heat the pad, you put solder on it, and the solder goes on that pad, and it tends to just go where you put it. It doesn't tend to go other places, because you kind of think, I'm going to be shorting this out all the time. That doesn't seem to be what happens. It just flows beautifully. Here's C1 and C2. So I'm going to heat the pad, add a blob of solder to it. Heat the pad, add a blob of solder to it. So that's half the job. That's half the job done already, and I haven't even got them out of the packet. Now I'm going to use my special super glass things here to just get in close to make sure that's right. Yeah, I think it seems to be. So what happens next? Well, you need your tweezers. Got your tweezers. Let's get out number one, which is this one here. Alright, there she is. Okay, it's on the floor. It's there. Can you see that? It's smaller than anything you could possibly imagine. Right, so with this particular one, there's no orientation required. It doesn't matter which way around it goes. With some others, because there's some diodes on here, they do matter. And I'll worry about those when I get to it. So you're just going to pick this up. Do you see? I picked it up. Picked it up, this tiny weeny little thing. And the plan is, need my glasses on for this, is you put it next to it, you heat up that same pad again, and you just push the little thing in. That's it. That's it. I mean, I can hold it again, just heat that up a bit more just to make sure that made complete contact. Yeah, perfect. So you heat up the pad where the solder is you've already put, so that that liquefies. You push the tiny little component into it and then release the soldering iron, and it's there and it's stuck. So I'll do all three before we solder the other side. So I'm just going to pick up the tiniest thing, placing it down, heating the pad, pushing it in, taking the soldering iron off and releasing. It might stand up a little bit, so I'm just putting the tweezers down on top, giving it a little bit more heat again, just to push it down. That's alright. It's not particularly straight, that one, but it's good enough. Take some of the solder off my iron, because it's very easy to put solder onto it when you're just dealing with these little pads. So I'll pick up this one, put it down, heat the pad, push it in, release. Put the tweezers on top, push it in, and it's down. Just awesome. Awesome, that is. Totally awesome. Now I need to put the tweezers down and bring some more solder into this. Now I might turn the whole thing round. Did you know you can turn PCBs round? It took me ages to work that out. I was just doing it all cack-handed before. So now we need to put solder on the other side of the capacitor. So all you do is get your soldering iron in there as best you can, because it's tiny. Heat the pad, add some solder. Like so. Heat the pad, add a little bit of solder. Now your soldering iron might be too thick, too fat to get in there. I mean, there's no special end on this, it's just the one that it came with. I'm not using anything particularly narrow at the end, and so it is a little bit tricky, but if you can just make contact with that pad and the end of that capacitor, there will be enough to do it. Just like that. Just like that. Oh, I just think that's brilliant. See, that looks like it's done. I think that's good. I think that's pretty good. So there you go, that's surface mount components soldered on there by hand. Oh yes. So I'll come back to the Infinite Machinery ADSR EG1 later on in the week, and that will be a serious surface mount project, because there's all sorts of ICs and diodes and bits and pieces that I've not done surface mount before, so that's quite exciting. So that'll do. I think that is a long-winded introduction to soldering. If you've made it all the way through to the end, congratulations, well done. You should give yourself a bit of an achievement badge or some kind of leveling up. But there you are. So this is what's going to be happening over DIY week. I'm going to be sitting here doing kits, some of it live streamed, some of it done beforehand like this is done, so I can edit it down and make it a little bit more contained, but tons and tons hopefully of good interesting kit making content. If you can join me for the live streams, that'll be great. I'll be publishing a schedule very soon, but it's a week from the 27th of September, a Sunday night, through to the following Sunday, I think, and almost every night I'll be doing a live stream of some kind of kit, including, as I say, the Frequency Central Stasis Leak, the Robo 3 PT. I'll be doing a Deckard's Dream. I'll be doing a chat with Steve from Thonk. Thonk is this fantastic shop down in Brighton that provides lots and lots of kits. It's the best kit shop in the UK, I think. And I'm also embarking on a project called Cosmo, which is the Cosmo format Eurorack, which is a bigger form of Eurorack that's been championed by Sam Battle of Look Mum No Computer. I'm hoping to start off a bit of a project on that as well, which should be quite good fun. So that's the rough plan for the week. There was something else as well, I can't remember what that was, but I don't know, we'll work that out as we go. But anyway, I hope that was helpful. I hope that was a good way to get us focused on doing that. I hope that you can see that both through-hole and surface mount are completely achievable by some idiot with a soldering iron. And you don't need a whole load of gear, you just need a little bit of space, some ventilation, some safety goggles, and some time. That's what it's all about. I hope that's helpful. In the meantime, go make some tunes.